No, the answer is not 3/7. That is a value we must discard due to the nature of the exponents. We start with this polynomial division that generates a notable quotient, and our goal is to find the value of m. By the notable quotients property, the division of the x exponents must equal the division of the y exponents. We equate both fractions and cross-multiply, moving the denominators to the opposite numerators. By solving the multiplication on the left side, we obtain the polynomial 5m squared minus 6m plus 1. We do the same on the right side, multiplying step by step to obtain 12m squared minus 65m plus 25. We move all terms from the left side to the right side, inverting their signs to equal the whole equation to 0. We reduce the like terms, achieving the quadratic equation 0 equals 7m squared minus 59m plus 24. We factor using the simple cross method, placing 7m and m along with the numbers minus 3 and minus 8. We group horizontally, obtaining the factors 7m minus 3 multiplied by m minus 8 equal to 0. Since the final product is 0, we apply the basic rule of setting each individual factor to 0. By solving, we discover two possible answers, where m can be 3/7 or the whole number 8. We discard the fraction because notable quotients require integer exponents, and we validate 8 as our correct answer. Now the big question arises of exactly where this fraction equality formula we used at the beginning comes from. To prove it, we applied the remainder theorem, taking our original denominator and setting it to 0. We move the negative term to the right, establishing that x raised to the m minus 5 equals y raised to the m minus 1. We take the first term of the dividend and cleverly rewrite it, isolating the base x to the m minus 5. We do the same algebraic trick with the second term of the dividend, expressing it with the base y to the m minus 1. Since we already proved that both bases are equivalent, we can freely substitute the base of x with the base of y. Knowing that it is an exact division, its remainder is 0, so we evaluate the original dividend by setting it to 0. We replace the terms we just transformed to have a single equation where everything is in base y. We move the entire second negative term to the right side of the equal sign to create a direct equivalence. By having the same base y on both sides of the equation, we conclude by simple logic that their exponents must be equal. And in this elegant and mathematical way, the origin of the formula we used at the beginning is proven.